Okay, listen up. This is 8.4a notes. So we're dividing this into 2 days, all right? Solving rational equations is what we're going to be working on today. At the beginning of the year, we learned how to handle equations with fractions by killing the fraction. Killing the fraction. And we did this simply by multiplying the entire equation by a common denominator. That's not changing. We're still doing that, okay? But a little factoring is going to be involved. But we'll start with the basic one. We'll start with one that we have already seen before, okay? So when I am doing these problems, the first thing I do is I look at all denominators. So if I'm doing that right now, my first denominator is an 8, and then I have and what else? Ooh, 13's not a denominator. Thank you, Riley. It's a 1. Perfect. It is a 1. Okay? So if I'm finding a common denominator, I need something that all of those numbers, all of those denominators will go into. Not a number that will go into them, but a number they go into. Okay? What'd you say? 24. Yep. I thought you said 4 at first. I was like, I can't hear. 24. You got it. So that is my number, okay? Then what happens is I distribute to every single thing that I have. And then what I do is I just multiply that 24 by the top and I leave the bottom alone. So 24 times 5x is going to be what? It's 24 times 5. So 120. 120x and leave it over 8. Don't change the denominator. Not yet. Okay, then we're subtracting. We leave that alone. 24 times 1. Okay, 24 over 3. Leave my equal sign. 24 times 5, x. 120, x over 6. And then 13 times 24. 312 over 1. With me so far? Now we just simplify. These are all monomial terms. So 120 over 8. What's that going to simplify to? What is 120 divided by 8? 15. 15x, okay. Minus 24 divided by 3.
8.
Equals 120 divided by 6. 20x, and then 312 divided by 1, we know that's just going to be 312. Can we solve an equation that looks like that now?
Yes.
Absolutely, okay? I'm going to write it over here just so I have room. If you write smaller than me, you'll be good. How do I solve an equation that looks like that? There's no parentheses. Combine like terms. Yep. I like to move the smaller variable first. So I'm going to subtract the 15x over. That leaves me with negative 8 equals 5x plus 312. Now I got to move the constant over. Negative 8 minus 312 is going to be negative 320. Set that equal to 5x. Divide by 5. Negative 64 is my answer. That's it. That's it. I'm done. Cool.
Wait, okay. I got lost track on how we got that 24.
That was the common denominator. So something 8, 3, 6, and 1 I'll go into. Okay? That's the hardest part, is just finding your common denominator. But we've kind of been talking about that, so what'd you say?
Are we just using it in the top? We're not using it as the denominator?
So when we are solving, that's a good question. When we're solving equations, okay, when we distribute that out, then we just have to simplify each term, and those denominators go away. Yeah. Yep. But just with equations. When it's expressions, you want to leave that denominator in your answer. Okay? So what do we do if we have a variable in the denominator? Nothing changes, okay? The only thing you really have to pay attention to is if you have extraneous solutions, and this is when the denominator equals 0. Okay, I'm going to show you how to check for that. We're actually not going to see it, though, until the next day of notes. So we'll go ahead. We'll look at this. So again, first thing I do check all these denominators. I got y, 2y, and 4. I want something that they'll all go into. Okay, be careful. So first we look at the numbers. So the numbers I see are 2 and 4. They both go into 4. Good. And then I look at the variables. What variable do I have? Y. Just y to the first. No y squareds or y thirds. Just a y. So just a y is all I need. And that's it. That's my common denominator. So now I'm doing that exact same process. I'm multiplying by every single term, just the top. So 4y times 3 is going to be 12y over y, minus 4y times 1, 4y over 2y, and 4y times 5. Perfect. And now we just simplify each individual term. So 12y over y, what's going to happen there? The y's are going to cancel. So we're just left with 12. Okay, 4y over 2y. It's going to be a negative. Yep, we're going to keep that minus sign. 4 over 2 is going to be what? 2 or 2 over 1. What about those y's? They're going to cancel too. So actually it's just going to be minus 2. And then we got 20y over 4. Just 5y. Now I just have 12 minus 2 equals 5y. That's pretty easy, right? 10 equals 5y. Y equals 2. Divide by 5. Good. That's it. Okay. Last thing, and I'm only going to show you this on this first one, just because, we're not going to see it today, but we do. Actually, we'll double check all of them, just to be safe. When I'm checking for extraneous solutions, okay, all I'm doing is once I get that final answer, so that y equals 2, I just want to plug it into each individual denominator and make sure that none of them are 0, okay? So first denominator, if I plug in a 2 for y, the denominator would just be 2. Is that extraneous? No, it's not 0. Okay, it doesn't equal 0. Would 2 times 2, would that equal 0? No, that would also not equal 0. And then I can't plug it into 4, so therefore I'm done. 2 is my answer. It works. So nothing is extraneous here. That's it. Okay? Any questions on that? Fun. Okay, now, what do we notice about example 3 that is different compared to what we just did? What do we call those things that we see there in those denominators? So far we've only looked at monomials. These are going to be binomials. Ooh, we've talked about these, okay? First thing we do when we see binomials is we check, are they factored? Meaning, can we pull out a GCF on either of those? Hopefully not. Yeah, hopefully you're shaking your head. No, we cannot. 3x plus 5 and 2x plus 5 do not have GCFs. Are those the same binomial? The exact same? Are they ever going to be the same? So you're saying they're not the same. So, when that happens, okay, just like before, if they are not the same, they're never going to be the same. We have to have both of them. So I need this one and I need this one. That's my common denominator. I need them both. So when I go to multiply, I am multiplying by the 3x minus 5 and by the 2x plus 5. I am multiplying by them both. And that is going to each individual term, and in this case there's only 2. So I multiply by the top, just like before, and I leave the denominator alone. So on top, I have 5 times 3x minus 5 times 2x plus 5. Or sorry, that's supposed to be a plus. Whoops. Over 3x plus 5. Equals 6 times 3x plus 5 times 2x plus 5 over 2x plus 5. Yes, but same process, and really you're about to see how they really aren't. Okay, I didn't have to distribute anything, right? All I did was I wrote out the multiplication problem on the top. and left the bottom alone, okay? So now I know that I can simplify factored fractions. I can simplify monomials if I have them, and I can simplify binomials if they're the exact same. Do we see anything that's going to cancel out on the first side? 3x plus 5 and then 2x plus 5 on the other side, right? So now my problem that I have, my equation that I have left is just this. Am I capable of solving something that looks like that? Yeah, we've been doing it. So on the left I would distribute. Yep. So this becomes. Yep.
Yeah. 10x plus 25.
Equals. Perfect. And now we need to combine like terms. I like to move the smaller variable, so I'm moving the 10x over by subtracting it. I'm also going to move the 30 over to the other side, so I get negative 5 equals 8x.
That cannot be.
Huh?
So that can't be anything.
It's going to be a fraction. We can have a fraction or a decimal. Yep, negative 5/8. That's it. All done. I would go and I would try extraneous solutions on that one. I'd go try to plug in negative 5/8 for both those, but neither one's going to be 0. So we'll go ahead and move on from there. Any questions on that, though? Everybody see how we did that? Okay, cool. Number 4. All right, I want you to try this one. Huh? So you check the denominators. You find a common one. You multiply it by the tops. Leave the bottoms alone. Simplify and solve. We got this. So we said that the common denominator is going to be 12, right? Okay, so that is going 1, 2, 3 places. Let's turn it off. Let's turn off the talking. Okay, when I go to multiply these, when I'm multiplying by a binomial, I don't need to distribute it out. I just need to write it like this. Don't put 12x plus 2, because then you're just going to have to refactor it. Okay? Same thing here. 12 times 4 minus x over 2 equals, this time it's monomial, so this time I can go ahead and multiply 12 times 3x, and what would that be? 36x over 6. So now everything is fully factored. I don't have to factor anything, okay? I can simplify each individual term. So the first term, the monomials can simplify with the monomials. What is 12 over 4? 3. So it's just 3 times x plus 1. The next term, 12 over 2. 6 times 4 minus x. Yep. And then 36x divided by 6, just 6x. Can we solve that? Yes, for sure. Yeah, now we distribute. Yep, because the fractions are gone. Don't distribute before the fractions are gone. Good. So we got what? 3x plus 3 plus... Yep. Perfect. On the left, what can we do? Combine like terms. So 3x minus 6x is going to be plus 27 equals 6x. Now what? Add the 3x. So 27 equals 9x, and last but not least, x equals 3, divided by that 9, good. And then we could go check for extraneous solutions, but I notice I have no variables in these denominators, so I don't have anything or anywhere that I could plug that 3 in, so I'm good. I'm good to go. Don't act so excited. 2 more problems. Okay, we can do it. 2 more problems, and then we get to do our homework. Fun. Okay. I'm gonna give you about a minute. I want you to go ahead and figure out what the common denominator is, and then go ahead and distribute it out.
Are you cracking jokes?
Am I cracking jokes?
Yeah, because
No. Okay, so we're doing the first step. Okay, we're finding the common denominator, and then we're multiplying it by each term. So just do that. All right, common denominator. We need a number and a variable that will encompass, guys. So we need a number and we need a variable that all 3 of these denominators will go into. And what's that going to be? 3n squared. We got it. 3n squared. So now that's going 1, 2, 3 places because there's 3 terms. What do I write for the first term for right now?
I know I did all the math right.
3n squared times 5.
Perfect. And the second term.
3n squared times 40.
Perfect. And last one.
3n squared times 5n plus 15.
Yay. Raise your hand if you made it that far. Cool. Like it. All right. First fraction, first term here. What can we do to make this simpler?
Cancel out the n squared.
Just the n squareds, right?
Yep.
So we are left with 3 times n minus 5
We're sure they're not n to 2.
plus, now the next one.
3 times 4n. Or 4n minus 24.
Good.
And then cancel out those n squared. And then it's,
What else will cancel though? Don't we have,
oh, the 3's
the
too.
3's cancel too. So this
yeah,
one's
I forgot
just
about
gonna
that.
be
5n
5n plus
plus 15.
15.
I
Good.
was scared for a second. I was like, what do you mean cancel out what? And I realized I didn't get to.
Gave you a heart attack?
Yeah.
Good, I'm glad you care that much. Okay. First, distribute. Yep, distribute. So what are we gonna get?
3n minus 15 plus
12n minus 72.
Minus what?
72.
Ooh, good. Okay.
Do it wrong, huh?
Combine like terms. What are my like terms?
3n and 12n.
What are those gonna add to?
15n.
Okay.
And then that one's negative 87.
Minus 87
And then
equals
5n plus 15.
minus the 5. I like it.
And 87.
And add the 87.
So 10n equals 102. And then I got 10.2.
10n equals 102. Divide by 10. 10.2.
Yo.
Who got that one?
Me, actually, that's for.
Okay.
Shut up.
Anybody confused on how we got that one? You can get a decimal
Keep
sometimes.
cracking
Yep, it's okay. It's okay. Any questions on that? Not yet. We got one more problem. Okay. Let me erase the black here so I can see. Okay. What are we doing? Let's do this one together. We're gonna do math, yeah.
Parentheses, because we already have our denominators.
Well, we're looking at our denominators, yeah.
Yeah, but you have to put the
X method.
We do have to do the X method. Why?
Oh my god, oh my god.
Why do we have to do the X method?
One of them is trinomial.
One of them's a trinomial. Don't they all have to be factored? Yeah. Unfortunately. What'd you just say, Timmy?
What?
Be a little more excited.
I could do this.
You can do this.
Top
I believe in you.
3,
Negative 3.
bottom is 2, and then it's gonna be, hold on a second. 2, negative 1, wait, negative 2, negative 1, I'm saying.
Multiply to negative 3. Add to 2.
Go ahead. You got it.
Not 2 and 1, but
Negative 2 and negative 1.
No, it's not gonna be 2.
Negative 1 and 3.
Negative 1 and 3.
There we go. Okay.
I said, I got it.
So my 2 factors then for this are gonna be what? Timmy, how about this? You get a 75% or higher on the next test. I bring the whole class donuts.
Oh, dude.
Why
come
me?
on.
Why you?
No, 70% you got.
70%. What did I get on the last test?
75%. Well, I don't know what you got on the last test, but 75% or higher.
Come on, you got it.
Let me check.
I'm gonna put pressure on you.
1 second. I just want to see you.
Okay. What are these factors though? Let's get through this.
Okay.
We just found them. X minus 1 and
X minus x plus 3.
x plus 3. Okay. So now we are looking at the denominators that we have. We're looking at the denominators that we have, and what do we notice? We notice the x plus 3s. What else do we notice?
Minus 1.
And we need.
I don't know, what do we need?
Starts with a B, B, O, T, H. Both. We need both. We need both of them.
BOT, binomials.
I heard B,
If I could do that one more
Oh
time.
my gosh, I heard I.
Wait, can I switch donuts out for something else?
What do you want? We'll think about it.
Listen, like, what about, like, some brownies or something?
I don't think that's what we're gonna do. We'll see though.
Something better than donuts.
Something better than donuts. Okay, here we go. Guys, listen to me, listen to me, listen to me. We're not gonna get done with this until we listen. Okay, this is our common denominator then. We have to have both. So we're gonna do the exact same thing as what we just did. The first one, we have x. We're multiplying it by that common denominator. And it's over x plus 3. Keep my plus sign. 2 times x plus 3, x minus 1, over x minus 1 equals, here we go, we got negative 3x plus 2 is a binomial, so we'll leave it in parentheses as well. So it's a lot of writing, but again, nothing too hard here.
Hey, I already found something we can cancel out.
Did you?
Yep.
What?
On that first one, you cancel out x plus 3s on top and bottom.
Okay, so we'd be left with x and
X times x plus x minus 1.
perfect, okay.
And then you cancel out the x minus 1 on the next one, and it'd be 2 times x plus 3.
I like it.
I'm going to last part yet, though. Hold on.
Okay. Everything else but the negative 3x plus 2, I would agree. Everybody see how we did that?
Yep.
Okay? So now, all we have left is to finish this. And it's an equation, and we know how to do those. So, first one, we distribute. What do we get?
X squared minus 1, x,
Plus
2x plus 6.
Good. Now what? Combine like terms. What are my like terms gonna be?
Negative 1, x, and 2x,
What does that add up to be?
1x.
Okay. And now this leads us into what we're going to end up doing next class. So I went ahead and introduced it, okay, just so it's not super scary next class. But this is what it's going to look like. When we have an x squared involved that does not cancel, that means we've got to get everything to one side and factor. Okay, there's going to be a couple of these on the test, so we got to know how to do it. So we want to move this 3x over. And we want to subtract this 2 over. So we end up with x squared plus 4x plus 4 equals 0. And to solve that, we're going to end up getting 2 answers. And how are we going to find them? With the X method, because it's a trinomial. Aw, don't cry. What goes on top?
4,
What goes on bottom?
4,
2 things that multiply to 4 and add to 4.
2.
2 and 2. So my 2 factors are going to be X.
2, and X minus 2.
No, one. They're both positive.
Or X plus 2, sorry.
Yeah,
I'm used to doing plus and minus.
that's okay. And then last but not least, we set each one equal to 0. And the first answer is going to be,
-2, and
and-
then one's gonna be -2.
yep, they're both going to be -2.
Cool.
And then we go up and we double check that one, make sure it's not extraneous, and it's not. So those are my answers, and we're good. Questions on that?
Nada.
Nada? Cool.